Okay, hello everyone. We are talking today about section 7.2, which is solving multi-step equations. And today our objective is going to be to learn to solve equations requiring 3 or more steps. Remember, we've talked about one-step equations, which are simple, single step and we're done. Two-step equations, which would include some sort of addition and or subtraction, as well as some sort of multiplication and division. That's a two-step equation. We need 2 steps to solve it. For this section, we're talking about equations that need more than 2 steps in order to solve them. So let's get started with a do now real quick. Once again, I encourage you to pause the video, try to do these on your own, and then restart the video to see the answers. And the reason for this is, let's be honest, if you can't do these, then you're going to have a whole heck of a lot of trouble doing anything else that we're going to learn today. So try these right now, pause the video, and then come back. Okay, so for number 1, we are into a single step equation. One-step equation, we see that we have 3 times x. So what we're going to do in order to solve this is divide both sides by 3 because division undoes multiplication. 3 divided by 3 is just 1, so those can cancel out. We get x is equal to 102 divided by 3. And 102 divided by 3 is going to be 34. X equals 34. Okay? 34 times 3 will give us 102, and we are good to go. Number 2, we look at and we see that we have z minus 100 equals 21. So, again, I'm doing number 3. Anyway, I'll do it first. Z minus 100 equals 21. I see that I have this minus 100, and I want to get rid of that. And the way I undo that is by doing the inverse operation, which is adding 100. Those add up to 0, so I can just cross them out. I add 100 to this. 100 plus 21 is 121. And so I will rewrite my equation. Z equals 121. And I am done. Again, you can check this. 121 minus 100, that does give you 21. Same thing over here. 3 times 34 does give you 104. Okay, we go on to number 2. Y divided by 15 equals 15. Well, how do you undo division? You undo it by multiplication. So I will multiply both sides by 15. I get the 15's on the left-hand side. 15 divided by 15 gives me 1, so I can simplify that by just eliminating those. And 15 times 15 is going to be 225, so when I rewrite my equation, I have y equals 225. Once again, I can plug this back in, 225 divided by 15, and check that I do get 15, and I do. Okay, so we move on. Number 4, I have 1.1 plus 5w equals 98.6. Well, this is a 2-step equation now, and I see I have this right here, this 5w, that's multiplication, so I can't undo that right now. I need to get rid of the other thing first, the 1.1, and the way I get rid of that is by subtracting 1.1 from both sides, and I will rewrite my equation. On my left-hand side, I get 5w, and on my right-hand side, I have 98.6 minus 1.1. Well, 98.6 minus 1.1 is 97.5, so I have 5w equals 97.5. Okay? And now I have a single-step equation. I have 5 times w equals 97.5, so I divide by 5. Those will, 5 divided by 5 gives me 1, so I can just not write those because 1w is the same thing as just saying w, so I will just say w. And then 97.5 divided by 5. Well, let's see. We can do that by just doing long division, or we can say, well, 100 divided by 5 is 20. And if I take away 0.5, I have 19.5. 19.5 times 5 would give me 97.5. You can also use a calculator. Any of these ways will work. W equals 19.5, and I move on to do a little bit of practice with my distributive property before I go into the main lesson. Remember, when you are doing the distributive property, you have a number times a set of things in parentheses. You can just do 8 times 2 and 8 times negative f. 8 times 2 is 16. 8 times negative f is negative 8f. And this is our answer. Of course, I like it with the variable in front, so I will say or negative 8f plus 16. And that's the way I would like it. Okay, now we have negative 3 times q minus 5. Again, this is just negative 3 times q, negative 3 times negative 5, but we need to be careful with our signs. Negative 3 times q is negative 3q. Negative 3 times negative 5 is positive 15. Negative 3q plus 15, these are not like terms. I cannot simplify it anymore. I am done. And we are done with the do now, so we go into the lesson for today. Okay? So, some types of multi-step equations is what we're going to talk about on this page. To solve a multi-step equation, you may have to... Oops. Not what I wanted to do. You may have to get rid of that. Okay? So we may have to simplify the equation first by combining like terms or by using the distributive property. And I want to highlight what we're talking about here before we go on. So the multi-step equations are different from one-step or two-step equations because we first have to do some simplifying of our equation before we can actually start solving it. Okay? So this word right here, simplify, is going to be the key word of our multi-step equations. And there are a few different ways that we can simplify things first. I'm going to talk about 3 of them in this lesson. The first type of multi-step equations we'll come across is solving equations that contain like terms. And we know that like terms in certain situations can be combined, and we're going to talk about those. The second type is solving equations using the distributive property, just like we did in the do now, numbers 5 and 6. And the third type is solving equations that contain, now don't everybody freak out, fractions. Fractions we'll find a way to make them go away, and the people will rejoice. Okay? So, what we're going to do is just go into this first type right away, and we have solving equations that contain like terms. So, let's look at number 1 here. First thing I'm going to do is I'm going to say 3x plus 5 plus 6x minus 7, well, I have some like terms here on the same side of the equal sign. This equal sign is very special. You cannot combine like terms on opposite sides of it, but for something that's all the way on one side or all the way on the other, we can combine like terms. So the 3x and the 6x we can combine before we simplify, or before we solve the equation. Likewise, the 5 and the negative 7, I can combine those before I solve my equation. Okay? So 3x plus 6x, the terms in red, are going to give me 9x. 5 minus 7 is going to give me negative 2. And the 25 is going to stay just like it is. Now I have a two-step equation, and I say to myself, you know what? I know how to solve two-step equations. Let me not freak out. Let me just do it. I add 2 to both sides, and I rewrite my equation. I have 9x equals 27. Now I have a one-step equation, which is really easy. I divide by 9, and I get that x equals 3. That was easy. And the only thing, again, that was different is that I combined my like terms first. The 6x and 3x, the 5 and the negative 7. Okay? So anytime you have like terms in an equation that you need to solve for the variable, make sure you simplify it first by combining your like terms. Number 2, we'll do another practice problem. Again, 8x plus 3x, those are like terms. 6 and negative 2, those are like terms. Okay? So, 8x plus 3x, well, that's 11x. 6 minus 2, positive 6 minus 2, is just positive 4. So I do plus 4. And that's going to equal 37. I'm drawing this line through the equal sign just to remind myself that this is a very special thing that we need to make sure we don't break any rules going between. So for an equal sign, you can do the same thing to either side of the equal sign, and you can do, at that point, anything you'd like. But when you're simplifying, like we just did, you have to stay on one side of the equal sign or the other. You cannot do something like this. 3x plus 4 equals 5x. Well, those are like terms, 3x and 5x, so it must be 8x plus 4. This doesn't work because you have tried to combine like terms across your equal sign, which is a no-no. Okay? So do not do that. Okay, let's get back to our problem. We have 11x plus 4 equals 37 after our simplification. Now we have a two-step equation, and I'm going to say, hey, those are easy. I know what to do. Minus 4 on both sides. Rewrite my equation. I wind up with 11x on the left-hand side equals 33 on the right-hand side. I can then see I have 11 times x, so to undo that, I divide by 11. I divide by 11, and I wind up rewriting my equation one last time. X equals 3, and there's my solution. That's all there is to it. So we've got a couple for you to try. Okay, no different than what we just talked about. You've got these four right here. You'll need to combine some like terms before you solve this, and then just solve the one or two-step equation that you have resulting. Okay, the second type of solving equation we're going to talk about today is solving equations using the distributive property. Okay, we have just a tiny bit of extra work to do in these kind of problems because we have this guy right here that just needs to be distributed, and that means 4 times x and 4 times negative 6. Okay? So, that's all I'm going to do first, and then I'm going to see what I have left. So, first of all, 4 times x is just 4x. 4 times negative 6 is negative 24. And once again, my equals 4 is going to come down. So I have 4x minus 24 equals 4, and I don't have to worry anymore because I now have a two-step equation, and I just do plus 24, plus 24. Rewrite my equation. I have 4x equals 28, and then I have a one-step equation. I have 4 times x equals 28, so I will divide by 4, divide by 4, and I wind up with x equals 7. And I say to myself again, that was easy. It's almost like we need a Staples Easy button. Okay. Now what we're going to do, first thing I'm going to do is shrink this a little bit because it's kind of in my way. Because I want to draw my arrows because I see, once again, I have the distributive property. 3 times x, 3 times positive 10. And I can rewrite this equation here. 3x plus 30. But here's where it's different. That's not all I have this time. Now I have some other stuff, and that other stuff will just come down. Plus 6 equals 12. Okay? Now I look at my new equation. I forget the old one because I've rewritten it. I look at my new one and see what I have to do. And what I see here is that I have some like terms on one side of the equal sign, this positive 30 and positive 6. So I can combine those before I do anything else. Positive 30 plus 6 is positive 36. Everything else will stay the same. 3x plus 36 equals 12. And once again, I rewrite my equation. And now I have a two-step equation, which by this point I'm saying, well, that's no sweat. Let me just do it quickly. Minus 36. Minus 36. 12 minus 36 is negative 24. What's left on the left-hand side is 3x, and so I rewrite my equation again. Every time I do a step, I want to rewrite my equation. so that I don't get anything confused. It's the easiest way to make mistakes if you know what you're doing on these things. Is if you try to do it in your head or do too many steps at once, it's very easy to make mistakes. So I have 3x equals negative 24. I say 3 times x. Well, I know how to undo that. That's divide by 3. Divide by 3. And negative 24 divided by 3, I get x equals negative 8. Okay? And I move on to the final one. First thing I see is, hey, I've got a distributive property that I can simplify my problem with, so I will do 9 times a. I will do 9 times negative 2. Well, 9 times a is just 9a. 9 times negative 2 is negative 18. And once again, everything else is going to come down. Plus 5a minus 5 equals 33. I don't have to worry about anything above my line now. This is my new equation that I deal with. And so what I'm going to do is say, hey, do I have any like terms? Sure I do. Negative 18, negative 5. Also, I've got 9a and positive 5a. So I'm going to rewrite these. 9a plus 5a is 14a. Negative 18 minus 5 is negative 23. And all of that is still going to equal 33. Once again, I wind up with a two-step equation and I say, no sweat from here. I know how to do those. I do plus 23 on both sides. I wind up with 56, and that is equal to 14a. Okay? And now I just have a one-step equation. I have 14 times a, so I undo by dividing by 14. Divide by 14, and I have that a is equal to 56 divided by 4. Well, 4 times 14 is 56, so a is equal to 4, and I am done. Okay? So this is step 1 and step 2, or first type and second type, are really not all that hard, because what we have done is we have just combined two things. We have combined distributive property and solving an equation, or distributive property and simplifying, or by combining like terms to solve my equation. And it's really that simple. You wind up with a two-step equation most of the time, and you can just stop. You can just go from there, because two-step equations you know how to do. Okay, sorry I had to pause the video real quick. So you've got 3 questions here to work on your own. Just involving the distributive property and then simplifying. So go ahead and make sure that you solve those. And then we are going to go on to the third type of solving equations, and that is solving equations that contain fractions. Now, I will take a moment right here to say that this is probably going to scare some students that for years and years have felt that fractions are too hard. This is not true, but
Amir and Samir Copper, please come to the main office.
okay, this is not true. Fractions are not all that difficult, but you do have to know the rules of them. So what we are going to do... Okay, so the third type is solving equations that contain fractions, and what we need to do is... well, we'll just read this statement right here in purple. If an equation contains fractions, it may help to multiply both sides of the equation by the least common denominator, okay, the LCD, of the fractions. This step results in an equation without fractions, which you will like, which may be easier to solve, okay? That might be a little bit iffy, but why don't we go through a couple of examples, and then you will understand what we're saying, okay? So we look at the first one, and we see these all have fractions. 4x over 13 plus 3 over 13 equals negative 1 over 13. Okay? So this is going to be a little bit complicated to solve. Not impossible, but a little bit complicated to solve. So what I will do is I will show you one trick. You can multiply everything in the entire equation by the same number, as long as you are in fact multiplying it by the same number. Here I'm going to multiply everything by 13. And when I say everything, I mean every single term on both sides. Okay? Now look at what happens. This 13, the first 13 I have drawn in, 13 and 13, those cross cancel. You get 1 and 1. This 13 and 13, those cross cancel, 1 and 1. That one and that one, 1 and 1. Okay? And look at what I am left with when I am done. 4x over 1 plus 3 over 1 equals negative 1 over 1. But I don't, because I have only ones, we all know how to simplify that. That's just doing this, taking the ones and removing them. So I am left with 4x plus 3 equals negative 1. This is a two-step equation that is super simple to solve. Minus 3, I get 4x equals negative 4. Divide both sides by 4. And I get that x equals negative 1. You see how easy that was once we got rid of the fractions? But let's do one that's maybe not quite so simple and see what's actually going on. We're not actually multiplying by the same number all the time. What we're going to do is multiply by the LCD, the least common multiple. And so we need to remember what that does. What we need to do is list out our factors of 9, 3, 2, and 6. How'd I pick those numbers? Well, very simple. What I did was I just said, hey, that's a 9, that's a 3, that's a 2, that's a 6. I need my least common denominator in order for this method to work. Okay? So what I did here is I'm going to list out my multiples. 9, 18, 27, and let's hope that's enough. Now I'll list out the multiples of 3. 3, 6, 9, 12, 18, etc. But I've already come across 18 and 18, and maybe I'll think that could be the least common multiple. Also, I have this 9 and 9. Maybe that could be it. Let's find out if I keep doing the rest. 2, 4, 6, 8, 10, 12, 14, 16, 18. Let's hope I don't have to go any more than that. And then for 6, 12, 18. I'm just listing my multiples. Well, I know I've seen 18 on all of them, but let's see if there's any smaller. The first one for the 9s is 9. 9 shows up there, 9 shows up here, but 9 is not a multiple of 2, so it's not going to be 9. We go to the next one for 9, that's 18. Does 18 show up for 3? Sure it does. Does 18 show up for 2? Yep, there it is at the end. Same thing for 6. So it looks like my least common multiple is going to be 18, because it is a common multiple to all of my denominators here. Now what I am going to do, pay very close attention, is I am going to multiply again every term by 18. That is my least common multiple. Times 18, times 18, times 18. And now let's look at what happens. When I do 18 times 4p over 9, I'm just going to worry about this one term alone. When I do that, I get that these cross cancel. 9 becomes a 1 and 18 becomes a 2. We know they're all going to do some sort of cross canceling because they have common factors. Okay, that's how we got the 18. Okay, so let's rewrite this. I have 2 times 4p. Okay, and that's it. It's all over 1. Okay, remember I still do. Let's see if I can get a different color here. Okay, one that will stand out. How about orange? Okay, I still have this 2 and 4p. Okay, so I need to make sure that I keep those. So 2 times 4p. But look, the denominator is 1. The 18 is gone. So it's just 2p over times 4 over 1. Okay, I will do that for each term. Okay, the 18 and the 3, those cross cancel. The 3 turns into a 1. Because they have a common factor of 3. 18 turns into a 6, because 18 divided by 3 is 6. And I get plus 6p over 1. I'll switch back to red. I have negative 1/2. Well, this 18 and the 2 have a common factor of 2. The 2 turns into a 1. This turns into a 9. And I have minus 9 times 1 over 1. And then finally, all of that is equal to this last term. And the 18 and the 6 have common factors. It's 6. So I divide by 6 on both of them. The 6 turns into a 1. The 18 turns into a 3. And I am left with 3 times 11, all of that over 1. Well, if you look at your expression here, all of these are over 1. So we don't really have to worry about keeping the 1s. We'll just rewrite this. 2 times 4p plus 6p minus 9, because 9 times 1 is 9, equals 3 times 11. Okay, now let's simplify this real quick. 2 times 4p is just 8p. 3 times 11 is just 33. And I'll go ahead and rewrite the rest of the equation. Plus 6p minus 9 equals 33. Now you have an expression that is only needs to combine like terms in order to solve. Okay? So we've got this 8p and the 6p. Those are like terms. We have the negative 9 and the 33. Those are not like terms. Well, they are like terms, but you cannot combine them because this equal sign's in the way. So all I can do is combine my 8p and 6p. 8p plus 6p is 14p minus 9 equals 33. And now it's just a two-step equation, like I've been doing forever. Plus 9, plus 9. I rewrite my equation. 33 plus 9 is 42. 42 is equal to 14p. And to get p by itself, I undo the multiplication by 14, so divide by 14. And I get that p is equal to 42 divided by 14, which is 3. And I am done. There are a couple of these questions for you to work on. I suggest that you go back and watch that section on fractions again if you need some. If you didn't get it the first time, try to do it again. But we are done with this video, and that is all.